Okay, welcome once again to an INB382 demonstration, and this video is about the refraction shader in CG. So as you can see, we have the Utah teapot sitting in the middle of the Sistine Chapel. Why, you ask? Because I can. So in this scene, we can see that when we zoom up to look at, or through, sorry, the teapot, we can see there that it's refracting the surrounding scene. So I set up a skybox with an environment map, cube map. That's all fairly straightforward. But the key thing here is you can see, for instance, that statue there is deformed by refraction through the surface of the teapot. And you can see that repeated elsewhere. You can also notice the sort of rainbow effect, the prismatic effect, due to the diffraction based upon different frequencies of light through the surface. So we simulate this very simply using the RGB channels. We show that in the shader in a minute. But as you can see, it's quite a pleasant effect. And we've also got a Fresnel effect and a mixing in of a bit of reflection. I believe we look across the surface, we'll see a bit of reflection there. Okay, so that's all very well and good. So how do we get ourselves a glass-looking teapot? Well, as usual, I'm glad you asked, so we're going to dive now into the shader. Looking in the shader here, fairly standard sort of inputs. We've got a normal, a position local, an eye position sort of calculation there. We can turn reflection on. Oh, reflection is actually off here. You can turn it on of your own accord if you want to and see the effect. It's all very easy. Then we go down here. If we want a Fresnel effect from total internal reflection, then we have a fast Fresnel using the Schlick approximation that's calculated here. All very good. And then we have the vertex shader here, covering your typical transformations of positions, world positions. We have a camera to position in world. So we've got a 2 vertex in world coordinates that we generate. So that's the I vector. From the camera position to the final position of the vertex in the world, and that's going to be interpolated by the fragment shader. Then we have our normal, what we do without our normals. And then finally, we've generated, we just spit out the local world position across to our output as well. All these things are quite useful when we get down to here in the environment map pixel shader. So again, normalize our input normal because it gets distorted a bit going through the rasterization stage, and also our I vector gets distorted. So the first thing is, if we have some reflection components added, we just calculate here from the cube map, which we pass in at the top here. Our reflection vector as per the environment mapping, so it's straightforward. Look at the theory on that. The new stuff here is with the refracted color. We use the same cube map because effectively we're firing a ray through the pixel, through the teapot into the surrounding cube map. The difference here though is we're going to bend it according to the law, Snell's law of refraction. Again, CG provides a nice macro to do this. It's all fairly straightforward. So we use the I vector and the normal at that point with a refraction index. Now, interestingly enough, we can therefore, for the 3 channels, R, G, and B, provide a different refractive index. And this refractive index difference causes the sort of prismatic effect we see around here. You can see how the colors are starting to look like a spectrum. So this is how we do it. So we do very, very simple approximation in the RGB channels. It's not correct, but it's enough to fool the eye into thinking that we're looking at some teapot made of crystal that is effectively acting like a prism and refracting light at different frequencies with different angles. So that's how we calculate our refraction color. So it's all fairly straightforward. It's one line of code for each channel. Then we calculate our Fresnel term, so in case we've got some total internal reflection. And then if we have the reflection turned on, we add reflection plus refraction plus Fresnel, scale appropriately, spit it out, otherwise just refracted and Fresnel, and then we have the output color. So I might turn, let's see what happens, it'll probably be buggy, maybe I turned it off before. True, not tour. And so when we play this baby, yeah, well, it's a pretty subtle effect, so we get just a bit of reflection on the surface. Yeah, I think I haven't factored it in that much. So anyway, this ends up being, so that's the end of the refraction demo, and we can see there that our teapot is see-through, and quite a useful effect to have in games for windows and various other items in your environments. Thank you very much.